Okay, here's some analysis on pandemic, but it's really how to coexist with pandemic, particularly the coronavirus. Okay, we want to find out how many testing we need to add per day. And we have two components to carry this out. We want to do physical simulation, and this want to know what we want to compute. We say it's a test to be added daily. And we do a little spelling in which we say the compounded interest and the compounded decreasing curves are to be drawn. And this is the compound interest. This comes from the compound interest equation. Okay, rate equal to change equal to rate raised to the power of 1 divided by length. Change, for example, could be double or half. Length could be every 3 days. As in change equal to 1 plus rate raised to power length. So that's basically the compound interest equation. Okay, now we just go right to the raised to the power, I guess. Okay, compound. Okay, we go right to the program that does to compound interest, draw compound interest curves. Okay. So it asks us tests to be added daily. Okay. Is equal to multiplication of two variables. Okay, it's the total test multiplied by 1 subtract rate add. Okay, I make a note of that because I will do the subtraction and add on this variable. Total test is going to be input. Yeah, that we know daily it's 150,000 as was CNN told me. And 1 sub rate add is just 1 subtract the rate. So the first variable is 1. The second variable rate add something. So the rate add is really calculated with a raised to the power. Okay. So we use modular program to find out here the raised to power. Okay. And it asks you describe root operator. Okay, the root operator is just the change, unit changes, either 2 or half, like a double or half, 1/2, 0.5. Describe the power. The power is 1 divided by length. Okay, the days in 3 days. Okay, so it's 1 divided by length. So unit change is either 2 or 1/2 or whatever have you. so it's input. 1 divided by length is, of course, divide 1 divided by unit length. Okay, could be 3 days or could be 10 days, whatever. Whatever they tell you, CDC tell you or lie to you. Unit length is going to be input. So we submit, then we give it the real value that CDC tells us. 150,000 tests per day. Then unit change is 0.1. Suppose we really wanted to drop. Okay, we want the rate to drop real fast. 0.5 is just drop, everyday drop by half. Okay, this is really fast to finish off the pandemic fast. And the drop 0.1 in 8 days. Okay. So here's the equation that we used. And the change is 2. Okay, double every 8 days. Initial value 7,000. Total length is 500. Okay. It showed how fast it rises. Okay. Now we're going to see how fast it's going to drop. 0.1 divided by 0.1 in 8 days. Okay, initial value is 150,000. Total length is 50. It's plotting on a 50 diagram. Okay, so we do a combine. We did the inflation rate and the testing rate, and that's what it found out. Okay, result and parameter. Daily test increase recommended should be 37,500 per day. Okay, if we can go this way, count in this way, and the infection increase rate is only 0.91, but the testing decreasing rate is minus 0.25, which is caused by this much increase per day in America. Okay, remember that. And the test to be, this is the calculation we did before drawing the curve. Okay, confirm. This is the plot. Okay, this plot shows if we do that much testing, we can get over the pandemic in 30 days with exactly